In this lesson, I want to introduce you to API versioning. If there is one thing that's true for our REST API is that it's going to evolve over time and is definitely going to change both in scope and in functionality. So we have to carefully plan how we will approach making these changes so as not to break our API clients. The bigger and more successful your application is, the more client integrations you may expect to have, and this increases the surface area for something to go wrong if you make a breaking change. We're going to discuss all of this as part of this lesson as we talk about API versioning. So let's start by understanding why we need to version our REST API. They say change is the only constant, and this is also true for REST APIs, where it's very common for functionality to be added or removed from the API surface. Our API is typically powering a business behind the scenes, and business rules is something that constantly changes as the business evolves and adapts to the changing landscape. This also means that our REST API will also need to evolve together with the business. And another change vector is our resource representations, which can evolve over time by introducing additional fields, becoming more complex, or even removing some fields from the representations, which constitutes a breaking change. Now, API versioning is a very broad topic, and how I envision this lesson is to simply introduce you to the different types of API versioning that are commonly used in HTTP APIs and also REST APIs. I will walk you through the 4 approaches that are most commonly used, and then we're going to discuss which one is the most appropriate for a REST API. In one of our next lessons, I'll focus more on the change management aspect of versioning APIs and how we can approach making breaking changes. So let me first introduce you to the most common API versioning strategies. We have URI versioning or URL versioning, query string versioning, header versioning, and media type versioning. Now let's try to understand what each of these versioning approaches means in practice. With URI versioning, we are making the API version a required part of our resource identifier. Typically, it will be the first value in the URI with a lowercase v and then followed by the version number and the rest of the URI. And here's an example of what URI versioning might look like in our get endpoint for fetching the habit. If we want to introduce a new API version, we simply define an endpoint that supports version 2 or 3 and so on. However, this versioning approach is problematic because it introduces additional meaning to your URIs. Let's say I have a specific habit and I access this habit using the version 1 endpoint. Does this now become a completely different habit if I use the version 2 endpoint? Based on how REST defines URIs, they uniquely identify our resource. And if I can get the same resource using 2 different URIs, then this isn't entirely RESTful. This is also why I don't recommend using URI versioning with REST APIs, but more on this later. Our second strategy is query string versioning. It's a bit more REST friendly because instead of making the version part of the URI, it's now moved to the query string as an additional parameter. This value can be required, but we can also omit it and assume that we want to use a default version if we don't specify it. This is something that we can configure on the application level. Then we have header versioning, which is implicit because we use a request header to specify our API version. Let's say that this is the API version header. We can also customize the name of this header. It doesn't really matter, but essentially we are passing in the API version using a request header value. On the server, we can then map this request to the appropriate endpoint where we can return the respective response. Compared to the first 2 approaches, this one is more REST friendly. It doesn't force us to make any changes to our API contract. Our URIs are still the same, and we also don't need to include any additional query parameters. We just specify the request header and use that to implement versioning on the backend. Lastly, we have media type versioning, where we can append the version number to the media type that we are sending as part of our API request. In turn, we end up doing content negotiation on our REST API to determine what is the appropriate response to return back to the client. This approach is probably the most RESTful out of the 4 that we've discussed so far because media types are already a big part of REST. In the previous lesson, I showed you how we can define our custom media type for representing hypermedia links in our resource representations, and we can simply treat appending the API version as another media type. This won't affect our API contract, and we can easily communicate with our API clients how to specify the correct API version, and we can even omit the version value and default to whatever is the current version when it's not specified. So these are the 4 API versioning strategies that we can use inside of our REST API. But what does the creator of REST think about API versioning? In short, Roy Fielding is completely against versioning your APIs. And really, there might be something here when you've spent more time considering what this actually means. A big disadvantage of API versioning is that when you introduce it in your API, you have to version all of your endpoints. The worst example of this is URI versioning, where the version number becomes a required value in the URI. In reality, you rarely need to version your entire API surface. Typically, there will only be a subset of resources that constantly change, and having to version your entire API to accommodate for this isn't the best use of your time or money, because API versioning also incurs a maintenance cost that you will need to pay to continue operating your REST API. So if we shouldn't be doing API versioning, then what do we do instead? And the solution to most of our problems is HateOS. Using Hypermedia, we can accommodate changing business rules by updating the hypermedia links that we return in our representations. Let's say you have an API endpoint that you return as a hypermedia link, but the business rule for this endpoint suddenly changes. Instead of having to version your endpoints and updating your hypermedia links, what you can consider doing is introducing another resource, another endpoint that's going to encapsulate the new business rule. Now, this is all assuming that you have to make a breaking change. We'll discuss more about this when we talk about API change management, but bear with me for now. So we include our new resource as a hypermedia link, and then we can instruct our client to move over to use the new hypermedia link. Because our clients can inspect the hypermedia links at runtime to determine what are the available operations, it's safe to remove the old hypermedia link and simply disable this functionality on the client. There is much more that I could say here, but I prefer using examples instead of theory. So let's wrap up this lesson where I simply introduced you to API versioning and the popular API versioning strategies, and in our next lesson, we're going to see how we can implement API versioning inside of our REST API. Welcome to our next lesson where I'll show you how we can implement API versioning inside of our REST API. We'll cover a few different approaches and start with URL versioning and why it isn't ideal for a REST API. And then I'll show you a better approach that uses media types to implement API versioning. I want to start by demonstrating what a breaking change is for our API. We're looking at the habit with tags DTO, which is what we are returning when querying a habit by the ID. Let's start the application and test out if this is still working. Here's the request that I want to send to my REST API. I'm including the habit identifier as part of the URI, but I'm also performing data shaping. And I want to select the ID, name, created at, updated at, and last completed at fields. So if I send this request, we will get back our data shaped response containing our hypermedia links because I use my custom media type in the accept header. We can even omit it and simplify our response to only get back the JSON representation of our resource. Now, let's say I want to adjust the names of these properties in my response to remove UTC. You might be thinking, okay, I just go back to my code and do a couple of name refactors. Now my fields contain the correct names and I can restart the application and everything should be working. And let's say I send the same request as before that was just working, but this time I'm getting back a 400 bad request. It says that the provided data shaping fields are no longer valid. So with a simple change like renaming our response fields, we introduced a breaking change in our API. Our data shaping is no longer working as expected, and anyone using the old implementation to support data shaping is going to get back a 400 bad request. And this might be the best option. If I were to omit the fields, then we will get back a response, but the names will be changed in the response, and the client application might even be silently failing without anyone realizing that we've introduced a problem. So renaming things is a breaking change for your API clients. So then what can we do instead? Let's revert back to the old state in our DTO, and let's see how we could solve this with API versioning. I will make a copy of my habit with tags DTO, and I'll create a new record. And I'll call this habit with tags DTO version 2. In the version 2 DTO, I will update my property names to have the correct values, and then let's move our DTO into its own file. Next, I need to update my projections. So inside of the habit queries, I will copy this projection here that was returning my old DTO and define a new one. Let's call this project to DTO with tags version 2. And we want to be returning the version 2 DTO as the result. So let me adjust this, and I need to fix the few breaking changes that I have here, and now my code should compile. So now I need to go to my habits controller, and I need to define a new version of my get endpoint. So this is the old one, so I'm going to copy it again and define a new one, and let's call this getHabit version 2. This one will work using our version 2 DTO. It's also going to return this DTO from the projection, so I'm going to update that. And then let's say everything else remains the same. But now we have a problem. The runtime is seeing this as two identical endpoints, and really there's no way to distinguish them without explicitly doing API versioning. Now we could do something like append version 1 or version 2 here, but that's not the way to go about it. There is actually a very good library that you can use to implement something like this. So let me show you. Let's add a new NuGet package inside of our project, and I'm going to look for ASP versioning. You might see some Microsoft packages here. All of these are deprecated, and the ones that you should be using start with ASP versioning. Now, the specific one that we need to install is ASP versioning MVC. This is the one that you should use if you want to work with controllers, which we are doing here. So let me install the latest version, and now we are ready to go. Now, if you want to use minimal APIs, in that case, you should use ASP versioning HTTP. And if you also want to support this in your OpenAPI documentation, then you will need ASP versioning MVC API Explorer. We won't be needing any of this for the time being, so we're good to go with just ASP versioning MVC. Now, one more thing I want to do is to update the NuGet package which received a new version, because I'm trying to keep the lessons to the most up-to-date version while recording them. So let's go ahead and update this to the latest version that came out recently. I will click update, and this will be taken care of in our directory packages props file. So now I can close this down, and I will navigate to my program file. From here, I should pick what is the most appropriate place to define my API versioning services, and let's, for example, add that inside of add controllers. But this method is no longer just about controllers. So let's rename it to become add API services, and I think this more closely describes what this method is doing now. It's configuring controllers, it's configuring serializers, it's configuring our output formatters, it's adding the OpenAPI package, and now it will also introduce our versioning services. So let me show you what we need to do here. I will say builder services add API versioning, and from here I can configure the API versioning options. Now it's also important to call add MVC. This is required if you want to use controllers. Now to configure API versioning, we'll provide a delegate to the add API versioning method, and we have access to the API versioning options. Here I can specify what is the default API version. Let's say that the default is version 1. You could also use major or minor versions or specify 1 point something. Let's also say that we want to assume that we should use the default version when it's not specified. So I will set this property to true. I also want to return the supported API versions in my response. So I'm going to set report API versions to true, and then I want to define my API version selector. This is how the library will determine what is the correct API version to use. I prefer using the current implementation API version selector, as this will always select the highest supported version, which is typically the latest version in your API. And then let's discuss how we actually read the API versions. You can configure this by setting the API version reader. There are a couple of implementations available by default. Header API version reader, there is the URL segment API version reader, query string API version reader, header and media type version readers. So let's start with the URL segment because it's the most popular one. If I close down all of the files and only leave my controller, here is how we can configure API versioning. I need to add my API version attribute to define what are the supported API versions inside of this API. So let's say we support versions 1 and version 2. This is how we could describe this on our controller level. But just doing this isn't enough. We also have to define the API version as part of our route. So we have to define another part of our URI, and we can use the API version route parameter to specify this. Now, when it comes to our API endpoints, we have to decide which one should map to which API version. For this, there is the map to API version attribute. So this endpoint should map to version 1, and our new endpoint should map to version 2. And now I can start my API, and if I try to send the same request as before, we will get back a 404 not found response. This is because I'm not specifying the API version in my URI. But if I say version 1/habits/the habit ID and send this